Hey, physics peeps. So we're going to take some brief notes on graphs. You guys did a lot of this the other day when you were recording with the motion detectors, how graphs look when something is not moving, when at constant speed, accelerating, decelerating. A lot of these things you want to be able to actually talk your way through and be able to kind of put together a picture of what these look like. And we're going to practice that today with some notes and some assignments. And you're going to be showing the guest teacher in the classroom what those things are. So yesterday, you should have that worksheet where you filled out all of these types of graphs for something that's not moving, constant speed, accelerating, decelerating, and when we're looking at position versus time and speed versus time. Again, we want to be able to look at our graphs and tell what is happening in terms of these shapes. And so if something's accelerating, the graph shape is going to end up looking like this. But if something's moving at a constant speed on a position versus time, it's a straight diagonal line because you're constantly moving at the same pace every single time. Sometimes not moving, flat line. But when you're looking at speed versus times, your graphs look a little bit different because your speed is 0 when you're not moving, or your speed is constantly a number when it's moving at a constant speed. So it's a flat line, all that kind of stuff. And so we want to be able to actually translate between them. Feel free to use that worksheet as a guide and have it out with you because you're going to be using it. But the point of this is to be able to actually go through a description and generate a graph and be able to put these things together on your own without that sheet if you can. So we want to build towards that direction today. But we did a little bit of this yesterday. Here's one other thing that you do need to know. And this needs to go into your notes. You will show that to your guest teacher here in just a little bit. It's the stuff that's here in the green box. And that's on a position versus time graph, the slope is equal to the speed. And so the greater the slope, the greater the speed. The less slope there is, the smaller their speed is. Because when we look at a position versus time graph, the slope, we say it's equal to the speed, and that's because when we say slope is rise over run, or kind of that y2 minus y1 over x2 minus x1, that's cool. But when we look at what's up on the rise part of the graph, you actually have this position. It's a lot like a distance that something is going. And then when we say the run is the time. And when we look at what we actually are doing, we're taking a distance, we're dividing it by a time. And that's an equation that you guys have already done. It's equal to the velocity or the speed. So slope is equal to the speed. Very cool. But the greater the slope is, the greater the speed. Less slope, less speed. All that stuff. You need to know that. You need to know that. Make sure you have this down in your piece on your notes because you'll show your guest teacher. Then, if we take a look at a graph like this, this position versus time graph is created for two small glider airplanes. Which glider is actually faster? You could actually tell by looking at the graph and the two lines that are made. So there's the blue glider, the green glider, and we could do this one of two ways. But we would say that the green glider, this one is faster, and this one's slower. Because one, looking at their slopes, the green one has a greater slope, so we could say it's faster. This one has a more shallow slope, so it would be slower. The other way you can think of it is that both of these gliders go the same distance from 0 to 25 meters. But the green glider takes less time to do that. It only takes 5 seconds to go through that. But the blue glider, it takes 10 seconds to go 25 meters. So the green one's faster, yep. But we can also do that just by comparing the slopes. Yay. And then what you're going to do though is I'd like you to look at this graph. This graph shows a relay race with Abby, Betty, Cindy, and Dana. Oh, it's really convenient on their names and their letters. But it shows them running through that relay race where they pass off the baton from one person to the next, all that stuff. What I'd like you to do is I'd like you to rank each runner from the slowest to the fastest person on that relay team. And I'd like you to go ahead and do that. You need to write down your answer in your notes, and then you need to go show your answer to your guest teacher in order to get the worksheet that you work on today. And so I'm going to pause the video, and then you'll go do that. All right, once you got this worksheet, you're going to start to create graphs from stories, because graphs, they tell stories of what's going on. So this is a little bit of what we're going to be doing. And this very first one, they show you an example of how we're going to do that. But the stories are going to be cute. But the first one starts off with the 3 little pigs. And when you draw a position versus time graph, you always start at the origin. So it's kind of like we are always starting at the beginning. Like in this one, the wolf starts from his house, the graph starts at the origin. But then when if the wolf, and that's kind of what we're showing here, is the position of the wolf in this the story. If the wolf goes to the straw house, the line, it moves upward. We say that it's just assuming it's going at a constant speed. Then when the wolf stops at the house to blow it down, then it's going to end up being a flat line. And because when you're stopped, it's a flat line. Then when the wolf goes to the next house, moving at a constant speed again, then stop, then go to the next house, and then stop. And that's where the story ends, because that's where he dies at a stew pot. It's good stuff. And on speed versus time graphs, that looks a little different, but these tell the same story, where he walks to the first house and then stops, walks to the next house and stops, and then walks to the next house and stops. The height of these graphs do tell a little bit of how the speeds go. I'm going to walk through the first one with you, and then we're going to try to and then you'll do this individually on your own. So when you actually are reading through this one's the story of Little Red Riding Hood. We're going to draw Little Red Riding Hood's graph as she goes to her grandmother's house. And so as we do this, we're going to read the story. We're going to make some notes over here on the side. I want you to write those notes as well, because they're going to help you construct this graph. And we're going to underline some information here too. Okay? So it says, for the first part, Little Red Riding Hood sets out for grandmother's cottage at a good walking pace. So when we say a good walking pace, this doesn't sound like accelerating. This sounds more like she is moving at a constant speed. So I'm going to write this down in there. I want you to write this down on your paper. You need to write down what's happening at each step, and then we'll end up drawing out the graph. But you need to show this to your guest teacher. And so the first part of the graph is going to look like constant speed. Then it says she stopped briefly to talk to the wolf. If you want to write down what's happening here, or if you want to underline things, you can choose. But it says that she stopped. That's another term just for she's not moving. That's easy. You guys know that. And then she walked a bit slower because they were talking as they walked to the wildflowers. And this sounds like she's moving at a constant speed again. It's not like she's accelerating, decelerating. It does say that she walked a bit slower. So our constant speed, it is going to be slower than the first one, and we'll see that. And then she stopped to pick flowers for quite a while. Oh, so she stopped again. So she's not moving. And then she realized she was late. Red Riding Hood ran the rest of the way to her grandmother's cottage. So she ran. rest of the way. But this part is also constant speed. Some people think this last part is acceleration. Just keep in mind that acceleration means that she's speeding up faster and faster and faster and faster. Constant speed is like you're going at one speed on its own. And so now that we kind of went through and we understand what happened in the story and we know kind of what the motions are, then we can start constructing the graphs. Let's construct one graph at a time. So when we talk about the position versus time graphs, we're going to start off with constant speed, but it starts here at the origin. So this is like where Little Red Riding Hood's house is from, or is at. She's going to be going to her grandmother's cottage. But constant speed, remember, that is a diagonal line on a position versus time graph. So we're going to start off with something like this, or as straight a diagonal line as you can make. And so constant speed, huzzah. But then she's not moving because she stopped briefly to talk to the wolf. When you draw this part, not moving, that's a flat line. But be careful when you do that. It's this type of flat line because her position's no longer changing. She's still right here. This is where her position is. And then she's staying at that position the entire time while she's talking to the wolf. And be careful that you don't do it this way. And I'm going to show you, don't do this. It's not this. That's not that she stopped to talk to the wolf. This is more like she teleported back to her house and was there for a little bit. And so don't do that. So stop to talk to the wolf. Huzzah, that's not moving. This next part is she walked a bit slower. So it's constant speed again. But we're going to continue on from where we were. But when she's walking slower, you got to think of how this looks. Because this, if you draw this is constant speed. But that's not saying that she actually went slower. That's like she went faster. Remember slope? Slope is related to speed on a graph, position versus time graph. So if she's going slower, it's probably just a little bit more shallow of a slope. So more shallow than this one. I'm going to try to draw that where it's more shallow. And then that's our position versus time graph. And we got up through this point, this point, this point. I'd like you to finish that position versus time graph with the other 2 points. And what I am so you need to finish it. It's not done. I'm going to start you on your speed versus time graph. And then the other ones, I'm going to just point out some things and then you'll be good. And so you're on your speed versus time graphs. You go through the story again, but you have to kind of keep in mind you're keeping track of speed. If you're moving at constant speed on a position versus time graph, that means that it is a flat line because you are starting at a speed and you are moving at that speed the entire time. So it's the same speed along that speed versus time graph. That's constant speed. Then she stops to talk to the wolf. She's not moving. But when you're drawing a speed versus time graph, it's not just flat and you keep going. Her speed becomes 0. So for that, we're just going to draw a straight line down and she stops to talk to the wolf. So even though, yeah, you got to slow down a little bit to come to a stop, we're just going to assume that you just come to a stop. You're good. Then she walks slower because she's walking and talking to the wolf as they walk to the wildflowers, all that stuff. But this is going to be a flat line again. We're going to draw a line straight up. But this time, if she's walking slower, that means her speed is actually lower. So we're going to draw this graph where it's actually a little lower than what it was before. And that's how we're going to end this part, but you need to finish that graph. And your other graphs, you kind of do in a similar way. Draw out your notes and then write out your graph. You should be good. Show your teacher, ask your teacher for questions. Have a good day, you guys.